So we found a little treasure in our cleaning the shop today, and this is um, an apple, a diamond apple. Kind of cool. And little green diamonds in there to make it even cooler. And cool stem, leaf. I'm not sure what it's made out of, like ceramic maybe, with a gold coating outside. Pretty though. They pop out of there pretty easy. Unfortunately, I have a couple of them and lost one of my stems that way. Here comes Yoda. He's gonna sing. This is how we sing in our house, and he sings when I make videos too. So there it is. A largish, small diamond. This is small actually compared to some of the ones I have. And the reason it does all those cool things with reflections and light like that is because it's a diamond. It'll glow in all wavelengths of laser light. And of course, my light's still on, so I can't show you. But it does, in fact, glow in all wavelengths. And there's the other laser. And boy, I can't shut the light off in this one.
Would you like the light off?
Not that light, the light on my phone. There it goes. Ah, ha, ha. Yeah, I would, Joe. So, isn't that cool? Look at that, huh? You don't see that kind of stuff every day. And it's glowing in like ultraviolet, right? Because of the carbon-14 in the populations of carbon. All natural carbon has all three isotopes of carbon, and diamonds are mostly C13. Carbon-14 has an extra neutron. So when you hit it with a laser light, that neutron gives off the mass of an electron at light speed. And that's what you see there, hitting the other side and glowing inside and all of that. It's the neutrons giving off all those electrons, and they do. They definitely do. Let's see what it looks like if I do it from down here. Look at that. Isn't that something? And it'll do it in all wavelengths. If it's clear or pink like this. Red ones sometimes don't respond to blue lasers. Blue ones sometimes don't respond to red lasers, depending on how the size of the planes of cleavage. See the stripes through the thing. Planes of cleavage are like that because all the carbon atoms are the same size and they line up in perfect rows and columns. Now, that's my pants, of course, but makes a good example. And they do so at a particular angle to the crystal lattice, because what you're looking at is the X and Y axis. as they cross each other across the z-axis. And the z-axis is right down the middle of this thing. And it's perfectly clear. You can see the stem up there perfectly, like there's nothing in between except the grunge on the bottom from my shop around here. But that's because it's C13 and it has double covalent bonds. And that's what makes diamonds so cool, is their clarity, their reflectiveness, their hardness, right? You can't scratch that with anything. I mean, I've had it bugging around my shop, and it's not scratched. And they are not rare or hard to find. They're just really, really beautiful. And they're also really, really useful because of a lot of these properties for things other than jewelry, like ball bearings and lasers and stuff like that. Stuff is not valuable for the number of pictures of dead presidents you have. It's valuable for what you can do with it. And you know what this one's value is? It's really, really beautiful. That's its value. It's a paperweight. Other than that,